So, welcome to lecture 43, standard template library called STL. In the last lecture, if you recall, we had talked about map and multi-map, all right. Also, we had seen set and multi-set. So, we completed with map and multi-map, and in today's lecture, we will talk about unordered containers. I will start with unordered containers. So, what do you mean by unordered containers? Right. So, the unordered containers you have like again unordered set, unordered multi-set, unordered map and unordered multi-map, right. So, these are all using hash tables, right. So, in fact, these unordered containers use hash tables. So, when you use hash tables, so you can have the fast access, all right. So, I mean you might have used the mod function, right, the mod operator. So, based on the mod operator you can define the function h of x is equal to with the help of a mod operator, all right, n mod k. So, something like that, or x you are using x mod k, correct. So, something like that when you use the function is called as the hash function, right. So, with the help of a hash, so I am not going into the detail, you just check how we can use the hash. For example, the mod operator when you have only a set of 11 elements, right. So, it will keep on moving, correct, set of 11 elements, assume that the array or the list contains only 11 elements, correct. So, from the 11 elements, let us say I want to insert 65, right. So, what is 65 mod 11, all right. So, it is nothing but 10, right, 65 mod 11, 11 into 5 is 55, remainder is 10. So, the 10 I can insert this key 65 in the 10th location. So, the hash function I am defining key mod the number of elements in the array, correct. So, h of key, I call it as a h of key, that is a function. So, that is called the hash function. So, these unordered containers they are using hash tables. So, this is for the fast access. So, for example, I want to search an element 65 in the array of 11 elements. So, what I will try to do, I will find out 65 mod 11 and then the 10th location I will reach directly, right, or I can access 10th location directly. I will find whether 65 exists or not. If it is not, I will keep on moving, right. So, compared to your sequential search of an array, this is slightly better, right. So, that is called the hash. So, in this case the unordered containers they use hash tables. So, this is mainly for the fast access to the elements and it will not use any specific order, right. So, without maintaining obviously directly I am going to the 10th location, correct, when in the case of key 65. So, the common unordered containers they are nothing but the unordered set that is storing a unique values or unique keys, and unordered multi-set that stores the duplicate keys. Unordered map stores the key value pairs with unique keys, and unordered multi-map, so these are all storing key value pair with duplicate keys. So, the operations, so whatever the operations, the dictionary operations that we can do, the average case is constant time complexity. So, if a number of elements is n, I can do it in order k, k is the constant steps, right. So, this is suitable for the applications where you do not require any ordering, right. So, that is called unordered. So, now initially we will start with the unordered set and multi-set, right. So, the unordered set it is storing a unique keys without maintaining any order, right. It is storing unique keys without maintaining any order, whereas unordered multi-set this is allowing duplicate keys as well and again not maintaining any order, that is why it is called unordered, right. So, these are all some of the functions or operations in the unordered set and unordered multi-set. So, you can have insert, right, insert function that is adding an element, erase removing an element, find searching for an element, and count, right. So, this is counting the occurrences. So, when you are using unordered multi-set, so this counting is being useful, and whenever you are having some data without any order, so this unordered set and multi-set they are useful for the faster access. So, let us take this particular example, right. Now, unordered set of numbers, right, that is an object, correct. So, here you can see, all right, the definition of unordered set stores unique keys without maintaining any order, unique key. But here we are finding out the duplicate key, that is why I have gone back to the previous slide. So, here we have duplicate keys 20 and 20, right. So, that is the initialization we are taking for the numbers. Unordered set is a class of integers, right. Unordered underscore set is a class that is under, you are including unordered set, fine. So, now this numbers, the object numbers which is invoking insert function, member function, and you are inserting 40, correct. So, when you are inserting 40, 40 will be added. In fact, the set contains 10, 20, 30, 40, but I do not know in which order I am going to get the output, alright. So, here you have numbers. So, numbers it is mapping to num, correct. So, that means both the address are pointing to the same location, and then right, in fact, it is a num 0, num 1, num 2, num 3. So, that will be printed, right. So, when I am running the code, you can see I am getting the output 40, 30, 20 and 10, okay. So, since first time I introduce unordered underscore set, so let us see how this is working in C++. So, we will go to the code, right, and next one unordered set, yes, here you go, numbers unordered set, I am inserting 40. So, you have 10, 20, 30, 20 and then we are inserting 40, same example. So, when I am executing and compile and run the code, so what is the output I am getting? I am getting 40, 30, 20, 10, right. So, this is unordered. Usually, the ordered one we know, ordered set we know it was giving 10, 20, 30 and 40, all right. So, what we can do, randomly we will insert one more element. So, let us say between 10, 20, 30, let us say 25, right. So, let us say 25, yes, and then if we add, let us see what is the output it is giving. So, we have included 25. So, you can see 25, 30, 20 and 10, right. So, this is a good example of unordered, right, because the previous one it was following descending order. So, you may ask the question, will it give a descending order, but this example is giving that. So, the first element is 25, then 30, 20, 10. So, this is a perfect example of unordered, okay, unordered set. But one thing you can find, there is no duplicate, 20 exists 2 times, but you can see the output 20 has been printed only one time. So, the next concept we will see unordered map and multi-map, right. So, the unordered map, so unordered, right, the keyword itself unordered. So, this is storing key value pairs and then you have a unique keys, but it does not follow any order, right. Whereas, the map we had seen the Alice Bob example, it follows certain increasing order, right, certain order, where here it does not follow any particular order. So, you call this as a unordered map, right. Similarly, you have unordered multi-map. This is also allowing duplicates with key value pairs stored in no particular order, all right. So, here the duplicate values are allowed, whereas the previous case duplicate values are not allowed in this case, right. So, whereas here in this multi-map case, the duplicate keys are also allowed. So, what are all the operations we can see? As usual, we can see the insertion. So, you can add a key pair value, all right. So, key value pair, and we can do the find, all right. We can use find operation or find function which is searching for a key, and erase which is removing a key value pair, and count, right. So, that is counting the occurrences of a key. So, this will be useful for unordered multi-map. So, when you are using unordered multi-map and then it is allowing the duplicates. So, we are finding out or we are counting the number of occurrences of a key. So, let us consider this example, unordered map, all right. So, I include unordered map as a header file, and under unordered map, so which contains string and integer. Previous case we had seen integer when you have a set, unordered set. So, string and integer, and then you are having age map as a object, all right. So, we will take a same example what we have done in the case of a ordered map or simply map, right. So, age map of Alice 25, age map of Bob 30, correct, and then auto address of pair, that means the base address, and base address of age map and pair pointing to the same location, and when we are printing pair dot first and pair dot second. Pair dot first is what, right, either Alice or Bob, because now we do not know what order it is following. It is exactly like how we printed, right, 25, 30, 20, 10 or 40, 30, 20, 10, right. So, one of them will be printed right now, assume that we do not know the output, right. So, the first one will be the name and the age, second one will be another name, right. So, it's because it is unique, right, another name and another age, right. So, this will be printed, right. So, in fact, when we run the code, we are getting the output Bob 30. You can see here Bob 30 we are getting first. That is what I said. Which one will be printed, I do not know. If it is an ordered map, we know that we are going to get it in an increasing order, that means alphabetical order. Alice will be printed 25. That is what I confidently told the output. If you recall what we have done in the case of map, ordered map, right. So, here Bob is getting printed first in this output, right, and then Alice, Bob colon 30 and Alice colon 25. In fact, we can check it, maybe we can add also some other name and then we can see what it is getting printed. First we run the code. So, here you go, we will see the output, yes, Bob 30, Alice 25. So, what we can do, we can include some other name, start with, let us say, Charlie. Age map, let us say Charlie starts with 25, 30, 35, we will put 35, all right. So, let us see how it is printing. Yes, you can see Charlie 35, Bob 30 and Alice 25, okay, 30 and 25, yes, all right. So, it is not following any order, it is not following any order. So, it is unordered multi-map, you can try with the same name, all right, and then you can check how the duplicate is being, all right. Here in this case map, if I put duplicate, it will not work, whereas in the case of try with the duplicate, all right, unordered multi-map also you can try. Or we can go back to the same, what we will do, we will put Alice is equal to 35. Shall we go back to the program? Yeah. So, what I will do, so here I put instead of Charlie, I put Alice. It is a map, right. So, we know that the duplicate should not exist, but we will see which output we are getting, right. So, it is the latest one, the old one is getting overridden and you can see Bob equal to 30 and Alice is equal to 35 we are getting, right. So, you can try what I am giving as an exercise, you try with the multi-map, unordered multi-map. In fact, we tried a ordered multi-map, right. In fact, I gave an example. Now, I am giving as an assignment, right. So, in the case of unordered multi-map, if you run the same code, can you tell me what will happen? So, 2 times Alice will be printed in that particular C++ code that we had just now seen, okay. So, now the next concept, iterators in STL, right. So, what do you mean by iterators in STL? So, iterator, which is nothing but an object, right. So, that gives an abstract way to access or you can say access and traverse elements in STL containers, correct. So, we can access and traverse with the help of iterators. So, this is nothing but the pointers, right. So, equivalent to pointers or acting like a pointers, right, to elements in the container. So, the container, let us say 1 to 10, right, or 10 locations. So, this is acting like a pointer. Iterators are nothing but the pointers, or you can say acting like a pointers to the elements in the container. So, what are all the operations they are supporting, right. So, you can access the elements, that means you can dereference this with star, all right, the pointers, and increment means you can move to the next location. So, when you want to move to the next location, you use plus plus, let us say iteration IT, right. So, if I put star IT, I can find out the value, IT plus plus, I can move to the next location, or minus minus, it will move to the previous location, right. So, these are all the operations the iterators can support, that means accessing elements, incrementing and the decrementing. So, accessing element, or when I want to print the element, I use star, the value, right, the dereference operator. The increment operator plus plus, if I use for one location, it will move to the next location. Decrement operator, one location, it will decrement to the previous location, right. So, when I talk about iterators, so the iterators enable the seamless integration of STL containers with STL algorithms, right. This is another powerful applications, all right. So, I mean, we can, in fact, we can find the integration of STL containers with the STL algorithms. So, these are all the types of iterators in STL, right, the input iterator. So, the input iterators that are reading the elements in a single forward pass, right, the single forward pass. You call it as a iStream underscore iterator. This is an example. And output iterator, write. So, the reading, now it is a writing. So, the writing elements in a single forward pass. Output stream, O stream underscore iterator is an example. So, now if you want to both read and write elements in a single forward pass. So, for that you have an example forward underscore list. So, you call it as a forward iterator, and then by directional iterators move forward and backward. So, one pointer is moving forward, another pointer moving from the backward. So, several examples you have. In fact, you can use it for the list and set. All right. So, for example, several algorithms like quick sort and all, you have to move right forward and backward. One pointer forward, another pointer backward. Right. So, that is called as the bidirectional iterator. And random access iterator. So, you can access any element in a constant time. So, for that you have the STLs, vector and dec. Right. So, in the previous case bidirectional iterator, you have list and set. So, here in the case of random access iterators, you have vectors and decs. So, let us consider the usage of iterators, particularly the basic usage of iterators. So, particularly when I want to traverse the element right in a container without exposing the underlying implementation. All right. So, I want to traverse the complete elements, let us say in a list, correct, and then I am not sure, I mean, what about the underlying implementation, right. So, without exposing, so you can do the traversal. So, the common functions for iterators are begin and end. So, it is returning begin, which is returning iterator pointing to the first element, correct, begin, and then end returns an iterator pointing past the last element, correct. So, it is pointing the last element, end, right. So, the containers, the example containers are vector, list and set, correct. So, in these containers, suppose I mean I am using the iterators. So, that is used to travel. For example, I am using the container vector or let us say list. So, under list I want to assume that I want to work it out for certain sorting algorithm like a quick sort. So, one pointer I want to have it in the begin, another pointer I want to have it in the end. So, that means it will be returning iterator pointing to the first element begin, and when it is returning the iterator pointing to the last element, it is called end. Okay. So, these are all the common functions where we can use it in iterators. So, now we will take this particular example using iterators with a vector, right. So, let us include vector, previously we have done, and in the main program I have the objects numbers, all right. I have the objects numbers and the class is a vector of integers. It contains 10, 20 and 30. So, now how do you use the vectors, right? How do you use iterators? So, now under vector, right, iterator, correct, it is like STD scope resolution operator C out, right. So, this iterator goes under vector of integers and that is a class, iterator is a class and IT is the object, IT is the object. So, now IT, we use IT for loop, IT numbers dot begin, right. So, the IT pointer is pointing to the begin, so IT pointer which is pointing to the address location of the begin, the first one vector, the first element of the vector. So, address of this, not the value, value is 10, right. So, the IT is now pointing to, according to this, IT is pointing to the address of the location where the element 10 stored, right, and this is the end. So, right now it is pointing here. So, the check condition is whether IT is equal to numbers dot end, right. So, if it is equal, so that is a stopping condition, stopping criteria, right. So, right now it is not, because IT is pointing to begin, right, it is not end. So, begin C out star IT. So, IT is pointing to the location of 10. So, when I put star IT, the value of that particular location. So, the value of that particular location is 10. So, I should get the first output 10, right. So, the now plus plus IT, this is what we said, right. So, plus plus IT will move to the next location, right. So, what is the meaning of next location? Next location is this, where the value 20 is being stored. So, star IT, we will get 20, right, in this location, right, star IT is 20, right. Now, again plus plus IT, so it is moving over here. So, IT is equal to numbers n, right, it is in fact plus plus IT, we are going to print star IT. So, 30 will be printed, right, and then your condition will be true, right. So, therefore, it will be coming out of the loop, right. So, it will be coming out of this for, right. Still it is being reached, the values will be printed, right. So, that will be printed under star IT, correct, right. So, that will be printed and you can see the output will be 10, 20 and 30. All right. So, when you run the code, let us go to the C++ code and C++ compiler and run the code. Iterator, yes, same example. So, you can see we are getting 10, 20 and 30. All right. Yeah. So, this is all about your iterators, and similarly we can have the reverse iterators. All right. So, the traverse from end to the beginning, right, the reverse way of traversal. So, in the reverse way of traversal, here you have the functions r begin and r end. R stands for reverse. So, this is returning the reverse iterator pointing to the last element r begin, right. So, suppose that the same example 10, 20, 30. So, your r begin is this, right, the function r begin, all right, and this is your r end, that is what the reverse begin and reverse end, and r end is this. So, r begin will return the reverse iterator pointing to the last element, whereas r end, that is returning a reverse iterator pointing before the first element, right, pointing before the first element, correct. So, the reverse iterators are supported by containers like, again same, the vector, list and deck. So, let us take the same example, but in a reverse way, correct. So, let us consider include list. Okay, so, here I am including list. So, numbers is an object, list of integers, the list of integers are 10, 20 and 30, right. So, now under list you have the class reverse underscore iterator and my object is RIT, right, reverse iterator. R stands for reverse and IT is iterators, reverse iterator. So, now for reverse iterator numbers begin. So, you have 10, 20, 30. So, it is beginning here, right, RIT is here, all right, RIT, this is not equal to, all right. So, it is printing star RIT. So, what it will print 30, all right. So, here plus plus RIT, the reverse, all right. So, therefore, this will move over here, that is the meaning reverse. If you put a IT, the case of iterators, all right. So, then it is a different story. If you put only numbers dot begin, all right, remove the word, then it will be a different story, it is moving. So, here in this case it will move in the reverse direction, correct. So, 20 right now it is not pointing. So, therefore, it is moving, all right. So, 20 is not pointing to numbers r n, correct. So, therefore, it is moving, right. So, therefore, it is moving plus plus RIT and then it will print star RIT, that means 10 will be printed. So, now it is already there. So, RIT is equal to numbers dot rn. So, therefore, it will come out of the loop by printing 30, 20 and 10, correct. So, initially when it is numbers dot r begin, correct. So, it is RIT is not equal to numbers dot rn. So, therefore, first 30 will be printed, then it is moving, plus plus RIT means it is moving, correct. So, now again it is not equal to this, printing 20 and then printing 30. So, now it is printing to the first, that means RIT is equal to numbers dot rn. So, then it is coming out. When it is coming out, it is printing 30, 20 and 10. So, when you are running the code, you should get 30, 20 and 10, right. So, in the C++ compiler, let us run this code. You call it as reverse iterators. Yes, you can see 30, 20 and 10. So, what we can do, we will put one more element, let us say 40, 30 comma 40 for our understanding, right. So, now when I run and execute the code, so I will get, you can see 40, 30, 20 and 10. So, from the reverse it is going, all right. So, initially the pointer will point to 40, so not at the end, all right. So, then it is printing 40 moving to 30 location, 30 it is printing moving to 20, 20 it is printing moving to 10, all right. So, 10 will also be printed and then it is coming out of the loop. So, in the next lecture what we can do, we will talk about this specialized iterators. So, in the specialized iterators, so we are going to see stream iterators and insert iterators, right. So, these two iterators we will see in the next lecture, right. So, now in this lecture we had seen up to iterators and reverse iterators. Thank you very much.